Hi everyone! Today we're going to talk about how to find the equation of a piecewise defined function just by looking at the graph of the function. To complete this problem, we'll identify each piece of the graph, then write the equation for each, and finally define the domain of each one. Let's take a look. In this particular problem, we'll be writing the equation that models the graph of the piecewise function that I've drawn here. Since we know we're dealing with a piecewise function, the first thing we should be looking to do is break our graph into different sections. With this particular graph, it's fairly obvious that we have one section from x equals 0 to x equals 1, a different section from x equals 1 to x equals 2, and a third section from x equals 2 to infinity. We'll need to model each of those separately in our piecewise defined function. Let's focus on the first section, the section from x equals 0 to x equals 1. We can see that this section intersects the points 0, 0 and 1, 1. Based on that information, we also know that the slope of this linear section is 1. So using the point slope formula for a line with either of these points will help us determine the equation of this section of the graph. If we use the point 0, 0 in our point slope form, we can say that y minus 0 is equal to 1, the slope, times x minus 0, 1 being the slope and 0, 0 representing the point 0, 0. When we simplify, we get y equals x, and we know that's the equation for this section of our piecewise defined function. We'll go ahead and call it f of x equals x. For the second section, we can do the same thing. We know it intersects the point 1, 1 and 2, 0. We also know based on these 2 points that the slope of this particular section of our piecewise defined function is negative 1 because we have a linear function running through the points 1, 1 and 2, 0, and the slope of that line is negative 1. So we can use again the point slope form for the equation of the line and say that y minus, if we use the point 1, 1, y minus 1 equals negative 1 times x minus 1. We can simplify that and see that we get y minus 1 equals negative x plus 1. When we add 1 to both sides, we see that we get y equals negative x plus 2, or f of x equals 2 minus x. Now all we need is the equation for our third section, and that's actually the easiest part because we can see that it's just the horizontal line y equals 0, so we can say that that function is y equals 0, or f of x equals 0. Now that we have the function for each part of our graph, we need to put them together as part of one piecewise defined function and define the domain for each one. When we have different equations modeling different parts of our piecewise defined function, we put them together in one function like this. We say that f of x, which will be our piecewise defined function, is equal to, we draw a big open bracket like this, and then use the information that we got from each of our functions here, x, 2 minus x, and 0, and we go ahead and write those out inside of our bracket. So we'll say x, 2 minus x, and 0, and now all we need to do is define the domain of each one of these. So we'll say that our function, our piecewise defined function, is equal to x if, and then provide the domain. Same thing here, it's equal to 2 minus x if, and then define the domain, equal to 0 if x is some domain. So in the case of f of x equals x, we can see that the function is defined all the way from x equals 0 to x equals 1. So we can say that f of x is equal to x if x is greater than or equal to 0 and less than or equal to 1. Our piecewise defined function is equal to 2 minus x if x is between 1 and 2. However, something we need to be careful of here, we can say 1, 2, and x here. Something we need to be careful of is that, remember we're trying to define a function, and functions can only have one output value for every input value, which means that for 2 minus x, we can't put x greater than or equal to 1 because we already put x greater than or equal to 1 here. And if we set x greater than or equal to 1 for 2 minus x, then we can run the risk of defining two separate output values for a single input value. So we'll just put x greater than 1, but less than or equal to 2. Same thing here when it comes to f of x equals 0. We can't say that x is greater than or equal to 2 because we've already said that it's equal to 2 here, so we just have to say x greater than 2, f of x equals 0. And that's how we define the domain for each section of our piecewise defined function. And that's it. That's our final answer. So I hope you found that video helpful. If you did, like this video down below and subscribe to be notified of future videos.